Okay, so we had a conference call today and we tried to figure out the best namings for some of these pins and standardize the pin based on whether you have the Citron or whether you have the IBT2. The IBT2 there's a lot of failures kind of with a lot of people, so really highly recommend using the Citron if you can use it. There's no reason that you have to use the IBT2 for anything. You can use the Citron for everything. So if you just cannot get the Citron and you have no choice, then the IBT2 is possibly another option to use. Okay, one of the things I want to talk about is hookup and pin numbers and that sort of thing. So there's these optically isolated inputs, and they're labeled steer, imp, and remote. And pretty simple. You can either hook a steer or a steer switch or a button to the steer input. And there's 3 pins on here. There's a power for like proximity sensor type switches. But if you're just using just a click switch, then you hook it to output. That's what the O stands for, and common. Zoom right in there. And these are the only 2 pins used. Don't use this because you don't need to power the switch, of course. And if you do hook up those proximity sensors, then it's brown, black, and blue. For brown, black, and blue to hook these up. That's those, you can see those other proximity switches. So the implement switch, you hook up in the middle one. And the turn sensor, like the sensor, well, it used to be called the encoder, but the encoder is a crazy name because you can use encoders on shaft monitors and all that other sort of thing. All you want to do with this input, this remote input, is to actually just detect when you're turning the wheel. That's different than enabling the Autosteer with the steer button. What this does is it opens and closes, and the program can count how many times it opens and closes, and you can set how many times it passes a magnet or how many magnets pass the switch before it kicks out the Autosteer. So you can set it anywhere from 1 to 255 or whatever you want, and that does accounting. So that's now going to be called a turn sensor. So when we talk about that, that's exactly what that is. So to hook up the board, you hook up your battery to your power, and you hook up the switch to turn the relay on. And that's all fairly simple, plus and minus. And then for the Citron, of course, you have positive going in and negative to ground. And if you're going to use the doubler, and you go from the switched output here, you go to your doubler, and then you come back with the yellow wire and hook that to the positive. Now you have 24 volts there, and then you just hook all the grounds together. So 12 volts out to the 24 volt doubler, and then back into the input. And then the motor, M plus, M minus, doesn't matter which way you hook it up, because we can set it in software if it turns backwards or not. Now the IBT2 and the Citron, the signals. So I blew up the input to the Citron, and it was hard to find a good picture of the IBT2, but it's the same pin. So you have this DIR1, PWM1, and PWM2. So for the Citron, all you need to hook up is the direction pin and the pulse width modulated pin. Excuse me. And that's PWM1 goes there. PWM2 can be used for your LED pin or your auxiliary hydraulic relay, or anytime that the Autosteer is active and actually auto-steering, this will turn on. Now the IBT2 is much the same way. You use the direction pin now. You use that for the LED pin or auxiliary hydraulic relay. So that's different than this side. PWM1 is connected to input 1. PWM2 is input 2. And that same direction pin is connected into those 2 enables. So when that goes high, that enables these 2 driver chips, and then depending on which one you send the pulse width modulation to, that determines which way the motor's turning. So you hook your 12 volts or your 24 volts from the doubler and to ground, and then the 2 wires off to the motor. The wheel angle sensor, it provides zone 5 volts, 5 volts in. The output goes to the high input, and the ground, of course, goes into the ground input. And that's it. If you want to use the differential one, well, then it's trickier, but you hook the ground to low and the ground to ground, and the high is still connected to the output of that sensor. I should mention one other thing. The 5-volt supply for the IBT2 comes from here. There's three outputs. You can have 5 volts there, and then the ground just goes to ground either from this ground, or you can connect to the main ground down at the bottom of the board down here. It doesn't really matter. Probably better to hook it down there because then it's single point grounding. And that's it. Not that hard to hook up. It shouldn't be too confusing, but I think this picture will really help. Just pare down to exactly just what is needed. And that's it. Okay, so now you've got it hooked up. Okay, so now we run AgOpen GPS. This is the first time it's been run. There's no configurations, nothing done. And we'll uncheck Show at Startup, agree to the terms and condition, which means you won't use it on equipment. And we're going to add in our camera. Let's just make this big. Okay, so here we have the board. Now I have two switches. I have the try to get my hand in there right over here. That is the turn sensor, and it's connected to the turn sensor input, the one closest to the corner. I don't have an implement switch hooked up, and then my steer switch, that's the steer switch, this guy over here, he's connected to this, and then goes around, and then is connected to this input here, just like the picture says. And then power and that sort of thing. This is just hooked to 12 volts right now. I just have a little tiny motor, and this is my wheel angle sensor. And of course the Arduino, and the ADD converter. And then I have right here, I have the red hooked to the 5 volts. The white center of the pot is my output into the high input, and the ground is to ground. And again, that's it. That's the only thing you need to hook up for Autosteer. You can see I have all the grounds coming to one place, all the positives coming to one place, all the grounds for all the driving, for all the relays, for the motor, everything all comes to one place. Now on the circuit board it's easier to do, but this is just a mock-up test station. But even with this test station, you want to make sure that all your grounds come to one place. Okay, so in the last video I just showed you how to upload the Arduino INO up to the Arduino. So, first thing we need to do, as always, is connect. I'm connected to COM5, and you can see there's nothing here. As soon as you connect, there's our information. And right away, you should see a 7. That's for your switch. The first two are the PGN numbers, and then this guy saying 381. Here, I'll just get rid of this. I'll bring this guy up, and then we'll go back there. Now watch this guy here, the 7. If I click, see it turns to 5, and then the 7, 5, 7. So then you know it defaults to a button, so that you don't have to change. This guy over here, what it is the wheel angle sensor. So if I move the wheel angle sensor, you can see it counts up, counts down. And it also is over here at the bottom of the display. So if you turn your tractor wheels, you should see movement. So before you do anything, if these guys aren't working, you've already got a problem. There's the GPS coming in. Make sure you've got GPS connected, or of course nothing works. But that's another whole video. And that's it. So then you know you've got communication. Things are happening. You can see clickety click. 5, 7. Okay. Make this a little smaller. Now the next thing you want to do is module configuration. So we're using the Citron. We're using single input. Inclinometer, none. We won't confuse things. And this comes up wrong. Even though it's a button default, this comes up as switch. I'm going to have to fix that, but it doesn't really matter because you're going to set everything anyway. We won't worry about these right now, and this still says encoder. We're going to turn this into turn sensor, but I'm going to leave it as encoder. But the next time you see the updated software, this is going to say turn sensor. And these are those counts. How many times do you want to push this switch up here, the turn sensor? Well, you know, right now it's 15, so it's got to go 15 times before it'll kick it out. So we're going to turn that into 5, just so it's easier. And of course the Ackerman, we talked about that, setting your steer angle, that sort of thing. So if we send this off to the module, there we go. Now you can see down here is the same sort of thing that we saw on the hooking up the USB. So if we tweak our wheel angle sensor, right, you can see it all. You can see it all happen, see it all work. Again, there's no point doing anything. And if there was roll and built-in B&O, those would be the numbers here. I have this temporarily hooked up as a to count the number of pushes of the turn sensor. So that's it. Do it again just to make sure. If you don't push that, nothing happens. I'll make this a little smaller. Okay, the next thing you want to do, of course, is our Autosteer settings. Proportional gain, that sort of thing. Make sure that they at least move one once somewhere so that it can write to the EEPROM the settings that you have here. We'll turn this guy up. We won't worry about that now. The whole thing is to start with known values, because in the EEPROM, in the Arduino, if it's a new one, it's all zeros. And whatever it defaults to in the default INO probably isn't the things that you want. So between sending this module configuration and doing the steer settings, before you do anything, just do that. Just send it some information, do a little change so that it can begin to start saving the settings that you want to save. All right, so now let's go into Autosteer settings. Put this guy up here, and we'll go into drive, and we'll turn drive on. But of course, nothing happens because we haven't turned it on. See, as you turn one way or the other way, now remember, I don't have these two connected. You're going to have your steering wheel connected to your wheel angle sensor. But in order to explain this, see, now that motor is turning this direction. If I turn it this way and back a bit, you can see how it zeroes out. You can see that in the steer chart. We may as well get 100 windows going here. So if I move this guy, so you can see it move back and forth. There we're dead on. Motor should stop, which it does. As we go one side, you know, now you have a negative. You go the other way, and you have a positive. So it just will turn the motor opposite directions. So again, if you get to this stage, you hit drive and nothing happens. Turn this back to 0. You can see that our set point line changes. So that's all we're doing, is we're just trying to make sure that everything turns the right way. And so that when the motor compensates and turns the steering wheel, that the wheel angle sensor is turning the right direction to zero that out. Okay. Now let's go back to module configuration. I don't know if I can do this. Nope. Let's turn this, say, to -5, or sorry, 10 degrees. And it's turning that way. Now we always say to the right is positive. But we're turning to the left. You can see this motor is turning left. So if we invert the steer direction, right, that changes the polarity of our motor. So now, watch what happens. We send it, Of course, it stops because we're resetting the Arduino. Now you see it's turning the other way. Now it turns the other way. Okay, so let's double check this now. See, the pot will turn the right way as the motor, and that's all fine and dandy, but what if it was the other way around? Suppose your wheel angle sensor is backwards. What's it going to do? Just hit the button. Hit the button here again. So now, if our pot tries to follow, see, it gets worse. So that's when you know that everything is backwards. Now you have two choices. You can invert the steer direction and send that, and then click this guy. So now when we turn our potentiometer this way, it balances out. So all you have to do is make sure that invert these or don't invert these, so that when you turn to the right, the angle shows up positive, and the wheel angle sensor gives the right voltage in the right direction to cancel out the direction that the steering wheels try to do. Otherwise, it'll pin one way completely, and then you know something's wrong, obviously. So I hope that makes a little bit of sense. And these are just all the things. We haven't driven anywhere. We haven't gone anywhere. These are the initial basic steps. So let's just undo these. And then see, it's back at 7 again. Turn him on. And it's working. If we set this to switch and send that, now, as soon as I let go, it's a switch. Now you can see my thumb there, right? If we put this as a button and send it, it's a click on, click off, as opposed to flipping the switch and then just leaving it there. Okay, steer sensor. Even though it's called encoder, it shall be called the steer sensor. We can enable this coder, and we have 5, and we'll send that. Now what we're going to do is we're going to simulate 5 ticks here. Sometimes it's 4, 2, 3, 4, 5. So that's like 5 magnets. When you're turning the steering wheel with a hydraulic system, you have 5 magnets that go past the sensor. That's exactly how many magnets will go by before it kicks out the sensors. You can see this is 7 now. Enable it. You can see the counting. 1, 2, 3. See the number here? 4, 5. And then we're back at kicking it off again. So that's just a counter. And when that counter exceeds the encoder counts, the steer sensor counts, then it stops it. If we set this to 1, send that off, enable it again, there, 1 kick and it's out. The B&O installed, invert roll, well, that all makes sense. If you turn to the right and it's a negative roll, well, we just hit invert roll and send it off. We don't have one hooked up, but that stuff is fairly basic. Min and max speed. Set it to 0 if you're going to travel 0.1 kilometers an hour, that sort of thing. You can set your minimum speed, maximum speed, whatever you want. And again, send it off. So we'll set it to 1, keep it there. Machine stuff, same way, raise time and lower time. If you want to send the machine PGN off to the Autosteer module, you turn that guy on. And that's it. Okay, now turn this guy on. See that? It's just a very simple control system. All the motor's trying to do is make the wheel angle sensor voltage the same as what you set here. So if we flick this guy around, there. In terms of gain, that's the minimum amount of pulse width modulation, the minimum amount of power to the motor. before it starts or stops. Output gain, you can see what it does. Just makes it go faster and faster. Whoops, can't have 0. Steer, wheel angle sensor. Here, let's make it kind of stop there. So now our wheel angle sensor, if we move the wheel angle sensor, again, it's position control. Now we just got to move this guy a little bit more. So when you're lining up your wheel sensor, set this at 0, send that off, and when your wheels say, when this says 0, the bottom bar graph is your wheels, and this is the set point. When that says 0, and this says 0, then you know you're really close. And then you don't need much. You can see as we turn it up and down, it changes our wheel 0. You don't need much. If you set the thing properly in the first place, then it saves you a lot of problems. Pure Pursuit. This is another whole video doing the Stanley and things like that. But you have convenient steer chart here. Remember again. See, now it quietens right down. It's hard to do this. I think you're getting the point of this now. You're getting to see the way this works. All you're trying to do is have the steer motor match the wheel angle sensor voltage. And that's it. Okay. And we haven't opened the field, we haven't done anything, but we know that everything works. We know that our switch works for steer enable. We know that our turn sensor, it works. We know that our wheel angle sensor, it puts out, the right angles. It puts out roughly the right voltage. When the wheels are pointing forward, it puts out 0. We know that the motor turns the right direction. And we know that the Cytron or the IBT works because the motor's turning. And again, if stuff is turning the wrong way, we can easily set that in the module configuration. So I hope that helps. I'll get the new INO, well, they're not really new, but just trying to figure out, like I say, whoops, there's too many things open. One sec. That direction enable pin is pin 4, pulse width modulation 1 is 3, and 9, that's been that way. The board you saw in the video here, or the picture, the webcam, is the original version 00 board, and none of this has changed. It's always been 4, 3, and 9. And D6, D7, and D8 are the remote pin, which is going to be the turn sensor pin. Just got to change some of these names, like I say. Work switch input is 7, and the steer switch is pin 6. Now you can make your own board, and you can turn these to whatever you want and change the code. But if you are putting answers on Telegram or on the forum, make sure that you say that I've built my own board. And when you ask questions on the forum, make sure you say, I'm using a PC board, I've built my own board, I'm using version 4.1, and I've downloaded the newest version from GitHub dated 26th of March or 2020. Because as soon as you say, well, my steer sensor doesn't work. I don't know if you're using version 307, 308, which I know, was it 2 years ago? Did you build your own board? Are you using a potentiometer? Nobody knows what you're saying or what you've used except for you. So be sure to give detailed information when you're asking about a problem, because then someone else has to ask, what version are you using? And that sort of thing. Highly, highly, highly recommend that you update everything to version 4.1 and the latest INO, because they just work better. As you can see, you can set everything. You don't need to adjust anything in the INO. And again, the wiring is very straightforward now. And all of this is just to try to prevent more mistakes. It takes less time to do things properly the first time, and then we will certainly try to do our best to make sure that things are consistent and straightforward hooking up as possible, because that really helps to eliminate a lot of the errors. So, bit of a longer video, but I hope you got something out of it. I'll be posting this in the news, so ask away. Thank you.